Hello and welcome to our lecture on basic tools for text mining in R. This lecture will provide you with an overview of some of the fundamental functions and steps one needs to perform to analyze text. When people think about big data, data analytics, business analytics, data science, they usually think of numbers. More specifically, they think of highly structured numerical data, something along the lines of an Excel-like table comprised of rows and columns where each cell in the table contains a number. So that's what people think about when they think about big data or data analytics. But most of the data available today is actually not numeric. It's something, it's something that is qualitative. So most data today is not numerical, it's qualitative. And the reason it's qualitative because one of the biggest, well, actually I probably should say the biggest repository of data nowadays is the World Wide Web. So this is where most data that human civilization has generated resides. And as you probably know, as an advanced internet or World Wide Web user, most of that data is text, something along the lines of, social media posts, web pages, and things like that. This data, not only it's not numeric, it's qualitative for text data, this data is also unstructured or semi-structured. For example, if you're talking about a web page, then the data, the qualitative data, the text that a particular web page contains, it's not chaotic, it's not completely unstructured. There is a markup language such as HTML or XML that is used to give this text some degree of structure. So once again, most of the data available today is actually not numerical. It's text data that is semi-structured or unstructured. R language has an extensive collection of packages and tools for working with text. By working with text, we mean a lot of things. We mean, for example, text cleaning, text organization, text summary and things like that. But one of the emerging and popular application of text or popular fields of text analysis is called text mining. So R allows one to perform all kinds of types and forms of text mining, and also R contains all the necessary tools or functions to do the necessary pre-processing and text organization before certain text mining tools can actually be applied to text. Usually text mining is defined as analysis of text for the purpose of identifying patterns. And specific examples of specific patterns can be frequent words or phrases. For example, if you're analyzing customer complaints, you may want to see what are the most important words in those complaints. That will help you to summarize a huge data set containing customer complaints and narrow it down to a few most common words or phrases that will hopefully contain those complaints. A more advanced type of text mining is called topic mining. Topic mining algorithms or tools, they allow you to extract topics from your text. For example, so it's not just a matter of finding frequent words or phrases, it's trying to make sense of what people are saying. So for example, from customer complaints, you may extract such topics as, usability, customer service, and let's say late delivery, right? So it will actually, those tools will actually help you derive higher level descriptions of the most frequent words and phrases and sentences that are found in text. So it's a more human-like, more sophisticated way of summarizing text. Also, you can see which words go together, which phrases are similar, linguistically similar, which phrases are likely to come from the same text or from the same genre. So those are the kind of patterns that you're trying to identify when you're performing text mining. Again, text mining is a vast topic. There are many books that are written about information retrieval, text mining, two related fields. In this example, we'll just go over some of the most fundamental steps performed as a part of text mining, and we will also see some examples of tools that can be used to mine textual data and also visualize the results of such a text mining exercise. In order to look at this example, we'll install several packages. These packages are already installed on my computer, so I'll just go ahead and I will load those packages. So if you don't have any of those packages, and most likely you don't, I suggest you pause this video and make sure that each of those packages is installed. So pause your video and go ahead, use the install packages command in R to make sure each of those packages installed on your machine. Just to give you a brief summary of what those packages contain and how they're used here, we'll go over these lines one by one. JSON Lite is a package in R for working with data in JSON format. JSON is a markup language similar to XML, although it's more modern and it's lighter, so a lot of people prefer to use JSON instead of XML for sending data, for transmitting data over the web. So there is a package that allows you to work with JSON data, more specifically to parse it from a JSON file into a text file or an Excel file, for example. As you can see from the name of this package, XLSX, it allows you to work with Excel files, for example, to open Excel files, to read Excel files, to write to Excel files, and things like that. TM, or text mining, is a very fundamental package in R when it comes to text mining, because it contains all the basic pre-processing tools that one can use to analyze textual data. Usually text mining package, or the package TM, is used as a part of more sophisticated text mining packages and applications. Snowball C package is used usually in conjunction with text mining. From what I understand, Snowball package contains some of the most common stemming algorithms. Stemming algorithms allow you to take text and derive the stems to summarize this text by deriving only stems, so that you don't have any kind of ending. So it's a way of summarizing and pre-processing data. Word Cloud is a package for creating word clouds. I'm sure you've seen those online. Those word clouds have been around for quite a while. At the very end of this exercise, we'll go ahead and create our own word cloud based on the text that we have. And then we have our Color Brewer package. It's basically a package that contains color. So we'll use this R Color Brewer package for coloring the words that we see in our word cloud. So the first thing we will do, we'll save data from a JSON file. Now, before doing all those operations, set a working directory where your where your files will be stored. In my case, I'm just saving everything to desktop. Also, be careful about this command. For example, I just realized, I was doing this exercise myself, and I realized that I cannot write to my C directory. So there's some settings that prevent applications like RStudio for writing anything directly into C. So that's why I had to settle for another folder. But naturally, for you, it's going to be probably a folder where you keep all your files related to R or this specific course. So I'll set a working directory for me as a desktop. Now, before I do that, I will just go ahead and activate or load all those packages that we'll be using throughout this exercise. So here I will go ahead and set my desktop as my working directory. And using this command, I will just go ahead and read a JSON file. So it's actually not reading JSON file, but I will use JSON file variable to save a URL that contains this JSON file that we'll be using. Jumping forward a little bit, here we are trying to analyze online data from a medical forum. So imagine there's a forum where people ask doctors questions about various diseases. So we just want to retrieve those questions and try to make sense of them. For example, we can see what are the most common questions asked by people, or what are the most common medical issues that people are facing. So those are the kind of questions we can answer by using this medical or doctor questions data set. So we'll just save the URL to this file in JSON file variable. And then from the JSON Lite package, we're going to use from JSON command to read this file and put it into a data frame. By the way, we're using flatten true option. You see, JSON is similar to XML in the sense that it's a structured markup language where things are nested. In XML, those are called parent and child nodes. So something like, because JSON is very similar to XML, we see something similar here. So we're going to flatten everything into one single text file. So we're not going to preserve any structure that is observed in the JSON, that is present in the JSON file. So we're going to read it. So here it is. So this is the kind of data set we're looking at. So here we have the name of the doctor who answered the particular question. So this is the question, this is question text. So there's a duplication. I guess it's a question name. And if a question short, it's the same as tag. So maybe those are identical variables. Tags, how this question was described using specific keywords, URL to this question, and then the answer that the doctor, this particular doctor gave to this question. So here we have one question about HIV test, and we had two separate doctors answering that question. So this is the kind of data set we're looking at. Specifically, we're going to look at question text because we want to narrow our analysis to questions only. So the first thing we'll do, we'll save the question text column. I'm talking about this column right here into an Excel file and also into a text file using write xlsx command from the xlsx package, and then using the built-in write table command. So this is how, just to show that it can be saved, this data can be saved into two different files. As you can see, it may take some time for you to save this data into a file. At this point, you can pause your video and go to your our current working directory to see what those files contain and how they look like. But what we're going to do next, after we save this file on our computer and we convert it from JSON into a normal text, what we're going to do, we're going to go ahead and open this file. So there's a file choose command in R that allows you to select a URL from which a file will be opened. So this is how it works. When you click on it, it will open a dialog box where you will open the file that you need. In our case, I will just open a medical file txt. I'm not going to deal with Excel, so I'll just point to this file, click open, and then the entire text from that file was saved into the text variable. If you look at the class of text, you will see it's a character, meaning it's a string. It's a huge string that contains all questions. Okay. Then after we put the content of the file into a text, we're gonna transform this collection into a corpus. In text mining, corpus is a collection of documents. You can think of it as, let's say, a collection of tweets where each tweet represents a separate document, because this is how analysis or text mining analysis is often performed at the level of individual text. So we're going to convert this text variable into a corpus right here, and then we're going to inspect. And when we run this inspect command, we'll see that we have 4,680 documents or specific questions. So we're going to split those questions into separate documents, and that's what our corpus represents: separate questions asked on that online medical form. So after we create our corpus file, we are ready to do some text cleaning, some pre-processing, something that is typically done before applying actual text mining tools. The first thing that we will do, we'll convert everything to lowercase. So we're going to use tm-map command from the text mining package to convert our corpus called docs into lowercase. So we run it. After that, we'll remove numbers because we're interested in text mining. We're not interested in numbers. Then we'll remove common English stop words to make the text more clean, more parsimonious. One example of an English stop word is the. This is something that does not really carry useful meaning, at least not at the level of applying the word frequency analysis that we will do here. So we're going to remove all those stop words. Also, you can specify your own stop words sometimes when you're cleaning text, like something that you don't want to appear in your text mining output. For example, I don't have a good example right now, but something along the lines of you're analyzing data, and let's say you're analyzing emails, right? And every email starts with something like hello or hi, and this is something that is present in every email, so it's not something that conveys any useful information. So technically speaking, hi or hello is not a stop word, but you may want to remove it. You may want to treat it as a stop word. So here we're just imagining that we have two stop words in mind, blah blah 1 and blah blah 2. So when you use this command, remove words, then those two stop words that you have in mind for your own text mining exercise will be removed. Also, you may want to remove punctuation, because again, punctuation, at least in this exercise, is something that does not carry any semantic meaning. And then we're going to remove white spaces. You know what this command does? It removes all the extra white spaces that you have in your document, something that reduces the size of your corpus. Now you can also do stemming. In our case, stemming means you're gonna derive stems from words. Okay, so you're gonna again reduce your textual data set even further. You make it even more parsimonious or simple. But we're not gonna do it here, because we will visualize words, and if we just visualize stems, it will be a bit unhuman-like, right? We want to do frequency analysis, and we want to visualize actual words as opposed to stems of those words. After we do that, after we do all this pre-processing to our corpus, we should go ahead and create a term document matrix. So a term document matrix is like a table, or more specifically a matrix. What it does, it finds different terms across all documents and then mentions how whether a particular term is appearing in a particular document or not. So remember, in our corpus we have more than 4,000 documents. So let's say we have one term that is called fever, right? So that fever will be one term extracted from that corpus, and then the term document matrix will indicate in which documents or in which questions, in which forum questions that term has appeared. So that's why it's called term document matrix. It breaks down your corpus into specific terms, and then shows specific documents that contain that term. So this is what we will do. We'll use the term document matrix function from the text mining package. We'll apply it to our docs corpus. So this is our document term matrix. It's a list that contains like that package. So one of the elements of that list is the collection of terms, and also with indicators where those terms appear. So what we will do, we'll convert this document term matrix, which is something that is specific to text mining, into a general matrix to be able to visualize better how it looks like. So if you click on M, which is a large matrix, you will see approximately what they mean by term document matrix. So somebody says anti, this is a term extracted across all questions, and it says that, okay, anti appears in document 2, 3, 4, doesn't appear in document 5, and so forth. So we have a huge collection of terms extracted from that corpus. Now what we want to do next, we want to transform this matrix into a frequency table. In other words, we want to see how frequent a particular term is across all documents. So what we will do first, we'll create a sorted frequency table. We're going to create row sums for matrix M. In other words, we're going to calculate how many documents contain this term, and that will also be our indication of frequency, how frequent that term is across different documents or forum questions, and we're going to sort it in decreasing order. And then based on that sorted matrix, because that's what the sort command does, it sorts the M matrix, we'll go ahead and create a data frame, and this data frame will contain actual word. So the column name, the first column name would be word, and we'll extract those names from the V matrix. And then frequency, how often, the second column will be frequency, how often that particular word appears in that sorted matrix. So that's what we're going to do. And then when we look at the head of D, oh sorry, something happened. Let's do it again. So here's D. So when we look at the head of D, we'll see that's what we're looking for. We have word, meaning term, and then frequency for that word. And then once we have everything sorted, every term sorted based on frequency, we'll go ahead and use the word cloud package to create a word cloud visualization. Before we do that, we use a setSeed command. It's a random number generated in R. It's a bit counterintuitive, like why we're doing it. Well, think about it. You see, like when word cloud package is generating a word cloud, there is some degree of random decision making as to how to arrange those words. So if you don't, so some of those decisions are made by generating random numbers. So by setting seed to 12, and it could be any number, you're basically making sure that the random number generated is the same each time word cloud is run. If you don't set seed, then whenever you run the script, your word cloud will look different, right? So we want to make sure that each time we execute that script, the word cloud looks the same, okay? So here we have some inputs, like where the words are coming from. They're coming from D, where the frequency is coming from, what kind of minimum frequency we want to see in our visualization, so at least one. Maximum words that we want to see in our visualization, what kind of order we want to have, and things like that. So you can look at it, you can take a look at the word cloud package and see what kind of parameters can be changed. Now, one parameter that we're doing here, we're using one of the themes from the color brewer package, to create colorings for word cloud. So when we run this command, we get something like this. So this is a word cloud. So as you can see, the word that is the biggest at the center is Spain. So that's why it's the biggest, because it's the most frequent word. And this kind of makes sense, right? Because I guess people don't go to a medical. In most cases, people don't go to a medical forum just out of nothing, right? Typically, they're suffering from some kind of pain, and that's what brings them to that medical forum to ask a question. So, as you can see, they also another frequent term here is question. This is like one of those stop words that you may want to remove, right? Because it's an online forum where people ask questions, so most likely they will start by saying something. Oh, I have a question, right? So it's something that present in a lot of questions, but nevertheless, it doesn't contain any. This word question does not carry any useful meaning. So you may want to remove that. Maybe now is another stop word that you want to click. So they talk about diagnosis, they talk about heart, they talk about problems, weeks, opinion, infection. So those are the kind of things that are people asking about in a medical forum. So that was a very basic text mining exercise in R. Nevertheless, it does introduce you to some of the main packages used in R for text mining, such as TM and Snowball package. It also introduces you to some of the most fundamental steps or elements in text mining, such as creating a corpus, creating a document term matrix, pre-processing or text cleaning, such as removing stop words, removing white spaces, and things like that. So most text mining packages, they require that sequence of steps prior to applying actual text mining tools. So the start, in many text mining projects and exercises, the start will be, the first part will be quite similar to what you did here. But again, R contains a vast collection of text mining packages. One of the most, well, maybe not the most, but one of the applications that is text mining applications that is gaining popularity, and everybody is discussing it and trying to improve this collection of method is topic analysis, where text mining can be applied to derive topics from large textual data sets. Again, I use this example where you have a big set of customer complaints and you're trying to derive the main topics. What are people complaining about? One thing that I did personally was a collection of reviews on Yelp from Mexican restaurants, and I derived topics, what people are talking about in those reviews. So some topics that come to my mind was something related to cleanness of those restaurants, like hygiene. So that was one topic derived from those Yelp reviews. People are complaining about hygiene or maybe praising hygiene. I remember the other topic was spiciness. I guess that's something that is relevant to Mexican cuisine. People were discussing whether a particular dish that they ordered at a particular Mexican restaurant is actually spicy or not. And there were a number of other topics that I derived from that Yelp data set that contained reviews of Mexican restaurants. Another text mining application that I'm quite interested in is linguistic similarity, trying to see whether two chunks of text are actually similar or not. There can be all kinds of applications of that. One application that I'm potentially interested in is grading student responses. So for example, a student writes a response to an exam question or an open-ended question, and then you have your answer key, and then you want to see how similar a student response is to an answer key, and based on that similarity score you assign a grade to a student. And then I'm curious to see whether this automatic grading is actually highly correlated or poorly correlated with human-like grading. I'm also interested in practicality of those applications. For example, what you can do, you can automatically grade questions that are kind of similar, and if something that is dissimilar, then maybe you'll have like a human to look at that response to provide a manual assigned grade. So again, it's a vast topic. This was just a brief introduction, but I hope that this introduction will enable you to look at more advanced text mining examples in R. Specifically, our next and final topic in this course will be machine learning. So some of the knowledge that we derived here, that was some of the ideas that were demonstrated here will come in handy, because a lot of times machine learning is also used on textual data. So we'll see how machine learning is applied to text to be able to predict and classify certain documents or text samples. More specifically, we'll look at a data set containing social media messages, and we'll try to classify those messages into bullying versus no bullying. And again, knowledge of basic text mining tools in R will come in handy when it comes to understanding the package that we'll be using for this machine learning exercise. So that completes our video presentation on basic text mining infrastructure in R. Thank you for listening.